Yes.
Question number 1 on the quiz said you had 25.45 grams of potassium hydroxide and 250 milliliters of solution. You had to calculate the concentration of the solution. This is a molarity calculation like the ones that we've been doing in the past. So in this case, the first thing we have to do is have to change grams into moles. And so we're going to take the 25.45 grams of KOH and we're going to convert it to moles. So I have 1 mole of KOH on the top, and I calculated the molar mass of KOH to be 56.10564 grams of KOH on the bottom. Okay? So when you calculate that out, you get a value of 0.4536 moles of KOH. So the first thing we did is we calculated moles of KOH. Second thing we're going to do is calculate molarity, which is moles per liter. So I'm going to take these 0.4536 moles of KOH and I'm going to divide it by the volume, which is 250 milliliters, but because it's liters, we have to move the decimal 1, 2, 3 places to the left because we divided by 1,000. So I'm going to have 0.25000 liters. And so when I plug this into the calculator and I calculate this out, I get a concentration of 1.84 or 1.814 molar KOH. Now some people did really well with the math part here, but they didn't label things appropriately. Yes, Gabby?
I thought that you said like that we should go to 2
For pH. Okay. Now I don't think I took off for sig figs on anybody's quiz today, but for pH, yes, to 2 decimal places, but in this case here, this wasn't pH, so I just calculated as it is.
So
Okay.
for our lab, what do you want us to do? Like,
Well, with the lab, I want you to follow sig fig rules, but because you're not calculating pH. Next one says a student takes a sample of the above solution and then goes ahead and dilutes it to 2.5 liters. So we're diluting it, which should have been a hint that you needed to use the M1V1 equals M2V2 formula. So we're going to use the molarity from the last problem, which was 1.814 molar KOH. And the volume in this case is 10 milliliters. I'm going to keep it in milliliters because it was easier for me to do that. You're calculating the molarity after we add it, or after we dilute it to 2.5 liters. So we're going to move the decimal 3 places to the right because we're going to multiply by 1,000. So it's 2,500 milliliters because they had to be in the same unit. You divide both sides by 2,500 and our M2 value is 0.007256 molar KOH. And again, that should make sense because we're going from a very, very high concentrated, very, very small amount to a very, very large amount, and then the concentration should have been smaller. I'm going to skip number 3 for now, and I'm going to come back to it. Number 4 says calculate the pH of a solution that's 3.64 times 10 to the minus 3 molar sodium hydroxide. In order to calculate pH, I need to use the pH equals negative log of H3O plus formula. Okay, that's the formula that I need to use. But because this is a base, and I know it's a base because of the OH, I know base, I know OH minus concentration. So I cannot take this value and just stick it into here. I have to change this value into H3O plus, and the way to do that is to use the KW formula. So KW is equal to H3O plus times OH minus. KW's value is always 1.0 times 10 to the minus 14. H3O plus is what we're trying to find. OH minus is this value right here. Because it's a base. I divide both sides. I divide both sides by the 3.64, and I calculate the H3O plus value, this time to be 2.75 times 10 to the minus 12 molar. So now I know my H3O plus, and when I put it into my pH formula, pH is equal to the negative log of 2.75 times 10 to the minus 12 molar. And so when I calculate this out, I get a pH value that is equal to 11.56. And here's a point where I'd want you to go to 2 decimal places because you calculated the pH. The last math problem says an HCl solution has a pH of 1.32. Find its concentration. Well, I want you to find the concentration, but all that I've given you is the pH. So the formula that actually equals the concentration is the one where you have H3O plus being equal to 10 raised to the negative pH. So I'm going to take this formula (10 raised to the negative 1.32), and so then H3O plus is equal to 0.0479 molar, and then that's the answer. You could have went further and calculated the OH minus. That wouldn't have been wrong. Now, the last question that you had to do is you had to write an essay or a brief paragraph about how to prepare a solution. And so these are the things that I was looking for. I wanted you to tell me that the student measured out exactly 25.45 grams of KOH using a balance. Okay. I also wanted you to tell me that the student filled the volumetric flask up halfway. I then want you to tell me that the student added the KOH to the flask and dissolved. And then I want you to tell me that the student filled the flask up to the fill line carefully to not go over. Okay? So that's what I wanted you to tell me. Note the phrases that I did not use here were actual masses and actual volumes. Some people said that the student measured out an actual mass and an actual volume, and that really just doesn't make sense. Okay? So I want to make sure that you understand these are the things that I was looking for. Also, big common mistake that people made is they said they filled the flask all the way up to the fill line, then they added the KOH to it. What's wrong with that problem? If you don't know what happens when you fill the bathtub up too high and then get in it, it spills out the side. When you add something, even though it's going to dissolve, it still displaces water. So you can't just leave it as it is. Any questions about the quiz? Okay. All right, I'm done.